So I was lurking GitHub a few days ago and I saw an interesting repo that I threw a star. And then it got renamed. This is that repo. Tanstack DB. Oh boy, this is an interesting one. If y'all aren't familiar with Tanner, you should be, especially if you're a React dev, because Tanstack Query, also known as React Query, is basically an essential dependency for all React developers. Tanstack's been building a lot of other cool things, like routers, forms, and much more. But now they're building a DB. Well, kind of. The role of Tanstack DB is fascinating, and I think there's a lot we can learn from it, but it's also one of the few Tanstack projects I am pretty skeptical about. There's a lot to dive into here. Why Tanstack DB exists, what it originally was, which is Tanstack Optimistic, how it works, what it's actually here to do, and why is Electric SQL involved. We have a lot to dive into. And even though I am an investor in Electric SQL, none of these companies are paying me. None of them even hit me up about this. This is all me wanting to deep dive and figure it out. So someone has to cover the bills. Quick word from today's sponsor, and we will be right back. Today's sponsor is one of those companies that makes me sound insane. And not just because they name themselves PostHog, as absurd as that is, but because the whole product is incredible. They offer an all-in-one suite of product tools, from analytics to session replay, experiments, surveys, and so many other really genuinely useful things. I don't know how I would run Ping and all my other products without it. I spend hours a day in their dashboards now. It's unbelievable how useful PostHog has been to us. And also cheap. Most companies, like over 90% of the ones using PostHog, are doing such for free because you get 1 million analytics events per month for free. And if you want, you can self-host it because it's open source. It also probably sounds made up that the only way I know what is actually going on with Stripe is through my PostHog template that they gave me with one click, but it's true. The integration there is nuts. And now I can very quickly link what users are spending what money in what places and how many messages are they sending and all that like chaos of data. Finally, it's all in one place that actually makes sense. And oh man, the LLM observability. If you have a product that has a bunch of different AI models and you're trying to figure out how much each one is costing you, how much each user is using, and all of that, with the LLM observability feature in PostHog, you can just wrap the calls with their helper. And now you get all of that data with no additional work to set it up. It's so useful. I look at this dashboard multiple times a day, every day. I'd give you a discount code, but I don't have one because it's probably going to be free for you. So check them out today at soydev.link/posthog. Before we can go too deep, we need to have some ground rules, understanding, foundations, whatever you want to call it, about what is going on here and why we should care. I'm going to start with a somewhat bold statement. Optimistic updates in Tanstack Query kind of suck really badly. So in case you're not familiar with the syntax, here's a basic example of a query using Tanstack Query. If you're, again, familiar with React Query, this should look very simple and familiar to you. You have the query key, which is the identifier for this query. You have the query function, which is a function, optionally asynchronous. Usually asynchronous is why you use query. And now the results of this request are in data. Is pending lets you know if it's pending waiting or not. There's also when it's loading, other states as well. And then error, if you get an error, like if the JSON fails to decode, you get that back here. This gives you all the states you need to interface with asynchronous data in your React apps. And the query key is particularly cool because it means I can take this query and put it in 5 places. And the query key guarantees that they can share one cache entity. The fetch only has to happen once and it can be referenced in all those different places. It's really nice. This example isn't type safe because it's a fetch call. We don't have type safety. But if you use something like TRPC here, it would be type safe, which is really cool because with TRPC, you know the type from back to front, and now you have the different states that you're trying to get in your client, along with all the type data you would expect too. So what's the problem? The problem is how optimistic updates work. So if we have a mutation, which is the other thing that React Query provides, is queries and mutations. Mutations are for things that change, queries are for things that don't. So on a mutation, like adding a new to-do to our to-do list, we post the new to-do to this endpoint. When that happens, we want to update the client with the updated list of to-dos. The lazy way to do this is to mark the query that has to-dos as invalidated so that it has to go be refetched. So what we're doing here is we call query client.invalidate queries with a query key. So as long as the query that we care about had to-do as one of its query keys, it will now be forced back into pending state and it'll have to refetch to get new data. Cool. But that's not very optimistic. First off, if you don't get the key right, or you're querying that data somewhere else with a slightly different key, then you aren't actually going to hit it. But more importantly, we're not updating it with the new to-do. We're invalidating it, so it has to do another network request response in order to get the updated state. So when you hit the submit button on that new to-do, you have to wait for 2 network calls. For the network call pushing up the to-do, and then another network call fetching the updated to-do list. So you're sitting there waiting on a gray screen, or sometimes not even, just you see the message disappear and you have to wait for it to reappear. Optimistic updates are hard. So let's see how we would actually make it optimistic. If you want to update the to-do right when you get the submission, so I get the new to-do, I fire the request to the API, but I also want to update the UI as quickly as possible. I'll have to call cancel queries on any currently pending queries so I know they won't override the cache update I'm about to trigger. Previous to-dos where I have to get from the query client the right query data from this key, which is not type safe, remember, because we're just randomly binding those keys in string arrays wherever we want. Now we have to manually set the query data and hope we got the type definitions correct. This is where the type safety of React Query falls apart, because there isn't a direct binding between this to-do key and the data that we are updating. So if this is expecting a string array, we could put a number in here accidentally and break everything, or we could put an object here accidentally and break everything, because there is no clarity between what this key is expected to map to, the shape of the data we get back, and the data that we update. All 3 of these lines here are incredibly untype safe and quickly can have problems if you change your keys or your expectations of the shape of data anywhere. The place that this gets worse is if we were to go change the shape of what is returned by the API endpoint, where instead of it returning a list of strings, it returns objects. Now we're just going to have random mutations all over our code base that are optimistically updating incorrectly and throwing errors. Couple good points from chat. This breaks a lot as your apps scale up. Imagine having to add filters on the to-do list. How do you handle the optimistic update there? What you'd have to do probably is you'd have to trigger the to-do list update with all of the data and then filter on client. If you're filtering on the server side and you're submitting a new to-do, you don't know if that to-do passes the filter that you have on or not. This stuff sucks. These are problems I would not wish on anyone. I've been there. I've done that. I hated it. You could also brute force type safety by doing a bunch of as bindings everywhere, or if you have all of your queries defined manually in a key value store somewhere, you might be able to force type safety here, but I haven't seen anyone pull it off elegantly. TK Dodo, the legend who maintains React Query and Tanstack Query now, has an incredible blog breaking down the way to think properly in React Query, and there's a new post that is focused entirely on optimistic updates. And as I read it, my head hurts more and more, because this is the most complex I've seen one of his posts have to get, because it's a complex problem. As he puts it, you have to recreate server logic on the client. With optimistic UI, you're essentially trying to foresee what the server will do and implement it on the client beforehand. So all the examples in here are actually not type safe either, which is terrifying. So this post is cool that it breaks down the timeline of when things are happening and changing, but fixing the consistency and type safety problem is non-trivial. The problem is if I call to-dos in 4 different places and I'm not very anal about making sure all 4 have the exact same type definition, or I give something else a different key, then I'm fucked. I have to make sure every single time this type definition is called, this key is called alongside it. If these 2 aren't always touching, everything falls apart. And there is nothing guaranteeing that they're touching. There is no link between these 2 things other than us putting them there. The type safety of React Query falls apart as soon as you leave the component you're in. That's just the nature of how React Query works. I'm not trying to, you guys know I'm a huge React Query fanboy. I need to highlight that these things being separate guarantees you have skew in your type definitions. Your types are not guaranteed to be linked. You've effectively guaranteed that at some point they will be unlinked. The solution to that is something like React Query Kit, which forces you to instantiate all of the query types via a create query call. Now you use this use post, and you can invalidate it by calling invalidate on this thing that now has types. This is how TRPC does it now with React Query too, but this is the solution you need. You have to build a whole fucking layer and package on top of React Query in order to fix this problem. So I think we've established optimistic updates in Tanstack Query, not great. hopefully you guys agree. Hopefully Tanner and crew aren't too mad at me for saying this. Optimistic updates in Tanstack Query suck. It's a combination of the data model simulating all of the horrifying things from the back end in order to make the UI do what it's expected to, the weird nature of keys being bound however you choose. There's a lot of pieces that make Tanstack Query not great for optimistic updates. So we've established this point. Now we need to talk about the two pieces here. Tanstack Optimistic, aka Tanstack DB. And we need to talk about Electric SQL. I'm going to start with Electric because I think it'll help a lot with the context here. Again, disclosure, I am an investor in Electric. I don't talk to them a whole lot. We disagree on a lot of things. Funny enough, I go to their meetups here and there, but Electric SQL is an interesting product. Their goal is to build a sync layer on top of Postgres. You have data in your DB, you replicate the portion relevant to a given user or client, and you fan that out to whatever clients it's relevant to. So when you make a query or a mutation, or more importantly, you make a change to the DB, the change gets sent out and replicated across the different clients. Electric's goal is to work with any Postgres database and any JavaScript-based client you want to connect things to. Now that means there's a lot of pieces they have to think about. They have to think about authentication, which is really difficult here because you have to know which rows in the database a user has access to, so they can't force it to sync someone else's data. So now you have to, at a database level, define your authentication. Row-level security is basically necessary in order to do these things. You also have to handle the client side and how you integrate the synchronized data, how you mutate the data, how you optimistically update the data, how you do all of that on client. Getting that right's really hard, especially if you're trying to make it integrate nicely with things like React Query. I know this because I've seen a couple different approaches historically. I saw how tRPC did it and then changed how they did it recently, and I saw how Convex did it, and they decided to just not use React Query in particular because the optimistic layer was not good for it. If we look through my code base for T3 chat, which we recently started moving over to Convex, hopefully it's the default by the time this video is out. We're trying to ship it officially by Friday if you want to try the beta, the opt-ins and settings. Here I have update thread title mutation. This is when a user updates the title for a thread. I have my API threads update call, which is a type-safe call referencing a backend function that exists here. And when this is called, I have access to my local store, which is my Convex storage, and the args, which are the arguments that were just passed here. If I call local storage.getQuery with this query identifier and this value, I know the type of what I'm going to get back. It's thread with parent or undefined. This is awesome because now if I make a change, I know what type I have to honor. If it does exist, if it's not undefined, then I find the current thread in this array of threads. I then return the thread with the title updated, and I then set it to the new object. This is still more steps than I would like it to be, but this is so much better than the equivalent with React Query, because instead of each of these being a violation of a type contract, each of these is fully complicit with the types. I am still replicating the server-side code myself because I am grabbing the query that is listing all of the things on the sidebar. I am updating the one that you changed, and then I am setting the new state. So technically speaking, yes, I am replicating the server-side logic. And if we were filtering on the server side, like your threads, hell, if you were searching for threads and you updated one of their titles, it wouldn't hit this. You wouldn't get an optimistic update on a thread that is coming up through search instead of through the traditional sidebar query. Still a lot better. But in the end, this is us replicating backend logic on the front end in order to show you the change faster than it waiting for the backend to send you the update. So how is this being solved by Electric? Well, Electric's platform and product isn't directly solving this. The Electric core thing, like if you go to GitHub, what they built here is a backend. Funny enough, written in one of my favorite languages, Elixir, which handles concurrent scaling, WebSockets, all these things really, really well. Makes a lot of sense they built in Elixir. I'm a fanboy. It's part of why I invested. But this is a server-side infrastructure for taking a Postgres database and synchronizing partial pieces of it across different clients. They have a cloud product for hosting it. And the most important piece, PG Lite. Sync into a lightweight WASM Postgres with real-time reactive bindings. This is a library that they built to have Postgres Lite, largely learning from the SQLite WASM project. PG Lite has the goal of letting you run Postgres queries and replicate Postgres data and patterns in the browser. So you can take a subsection of your database, put it in the browser, and query it. And it works in WASM, so it works anywhere that WASM is supported. All of these come together with the TypeScript client from Electric that lets you create a shape stream. Their concept of a shape is their abstraction on a table, like something in your schema, in order to give you the primitive that you're querying against, the tables it has, and the shapes of the parts that you can get from it. So here we create a shape from this URL with these parameters. Then we can create a shape from this shape stream that will automatically update or call its subscribe function when changes that are affected from here occur. So you can build on top of this a pretty powerful sync engine that will take a given endpoint, connect to Electric on the back end, see when something changes that's relevant to your query, and then fire this update when that happens. But as you can guess, looking at this code, not going to be very fun to build the whole sync engine and layer for this yourself into your application. So what do you do now? What most people do is they build a React library, which is why we have Electric SQL/React. This is their React hooks in order to bind a given URL and the parameters you're passing to it with Electric SQL on the back end to get that data on the client and have it auto update when it changes. I would imagine this package has very little code, but more importantly, this package is probably not super well maintained because it's not core to their business in the sense that it is not the thing they are selling. They are much more focused on the infrastructure side. So how do you handle that? If you have a React package that's kind of just sitting there, 20 lines of code, trying to replicate the shape of Tanstack Query, you want to focus on the infra side, and the core problems you care about, like optimistic updates, aren't well solved with the ecosystem. So you can't just build into Tanstack Query because it's not going to solve the problems that your product is built to solve. It's not going to let users take advantage of how easy it is to do those things. Because Electric SQL has replicated the DB, it can just write the change locally and update you immediately. But if you can't optimistically do things with it, it falls apart. They have examples here using Tanstack Query, and you'll see how quick they get super complex because it has to write all these crazy additional hooks, including the use mutation state, to show the temporary mutation data. Instead of adding it to the data from the query, they now have a case in render where if they're not in a clearing state, they create a map of items where they take the ones from the query and they add the ones from the mutation. So your render code has to get fucked in order to trigger this optimistic update. It's rough. And that's the point where they decided to reach out, not to try and bully Tanner and TK into fixing optimistic updates in React Query. Instead, they recognized how big of a gap it was to care this much about local optimistic updates and proposed a new solution, which was Tanstack Optimistic. And now we have finally made our way to what we're here to talk about today, Tanstack Optimistic, which just got renamed to Tanstack DB. Let's see how they describe it first and foremost. Tanstack DB is a reactive client store for building super fast apps on sync. Extends Tanstack Query with collections, live queries, and optimistic mutations that keep your UI reactive, consistent, and blazing fast. Prime reference. Here's the post on Twitter that I think does a good job of breaking down why this exists. Tanstack DB is a reactive, normalized, transactional state engine that extends Tanstack Query. It gives you collections with live queries, sub-millisecond incremental updates via differential data flow, fine-grained reactivity for minimal re-renders, robust optimistic transactions with sync lifecycle support, and normalized data by default. Think of it like Tanstack Query meets client-side databases, perfect for local-first, collaborative, or offline-friendly apps. As someone who tried building this myself, this sounds very nice. I've been in hell building sync engines. It's backend agnostic, incrementally adoptable, works with REST, GraphQL, sync engines, polling. You'll see GraphQL come up a lot in this circle because one of the co-founders of Electric is Kyle, who's also the creator of Gatsby. I won't make further comments on what that does to my thoughts on where this could go. The pairing seamlessly with Tanstack Query is the part I am the most excited about by far. So what does it look like to use? Well, first we have to create a query collection. As a query key, query function that actually gets the data, an ID, so that we know how to get IDs out of this collection of to-dos, so that each item is uniquely identifiable, so we can do granular updates. Because if we change one to-do in a list, but we're getting the whole list as a collection. We don't want to re-render the whole list. We want to just re-render that one item. So each item needs to be identifiable, similar to like a key when you're rendering a list of stuff in React. And then the schema, which is any standard schema. Think Zod, Validbot, archetype, those types of things. So now we can get our data, which is to-dos, from the live query from Tanstack/React-DB. And that is a query from to-do collection where @completed, which is a field that the schema has defined, is equal to false. So this will give us all to-dos that are not completed. There are catches here, though. You might be seeing them. The one I am seeing, what the fuck is this? There is now yet another query syntax being built. We'll go into why I'm skeptical about that in a little bit. What I want to talk about is the optimistic part. We now have a use optimistic mutation hook. Const collections, comma, modified, new to do. We have this transaction. We're grabbing transaction.mutations 0. So the first thing from this list of transactions, in case you batched a whole bunch, but it might not exist. So you have to do an exclamation point. We're already losing type safety points. We then await api.todos.create, new to do, await collection.invalidate. Huh? This is not everything we were just doing? Where does this even get the thing that it's operating with? Oh, on click, add to do.mutate. This has the transaction passed in line when we do it. So we don't write a mutation that this optimistic mutation works against. We call this as a generic and we pass it the mutation we actually want to do in the collection we want it to operate against. Yet implementation details are leaking here. This is why I'm confused about this. On one hand, it's more type safe because it knows what to-do collection is. But on the other hand, this is taking the problem with React Query and making it 10 times worse. Because in React Query, a given use mutation call has one mutation function that it is bound to. A given to-do mutation that you have will closely tie the behavior of the mutation to the optimistic update behavior too, because they're the same mutation, and that one mutation can do the one thing. What happens if I pass a different transaction to add to do? Everything falls apart very, very quickly. If I had a different thing I was passing here, like update to do, and I accidentally called this, or if I had named this instead of add to do, mutate to do, what we do in it is we create a to do, but if we accidentally did something else with it, it's going to break really bad. The fact that these implementation details are leaking between here and here, instead of being defined in one place and then called in others, is terrifying to me. The closer your update and your logic are, the easier life gets. And this is, again, something like, I hate to just be plugging Convex this whole time, but one of the things Convex does really well, I have this client-side front-end code where my existing threads are being grabbed from this query that I fired other places. I have the type definition here for it, but more importantly, if I command click, it brings me to the backend function that actually does this. And yes, they have their own weird syntax here to an extent. Their weird syntax is how you hit things with indexes. Where things get really fun is when you want to do something like link data, like I do here where I attach parents to thread. You would think that I would include that in the query semantics here like you would in SQL. But due to the way Convex works, I literally just map through them and await the fetch to get the parent. Yes, really. You just map through or for loop through all of the data and just query for each row. It seems insane, but the way Convex works is it flattens all of these into a single transaction, so it ends up still being really fast. It's a lot more nested than I normally like. People are calling that out in chat. You're correct, but it's fully type safe and it is just JavaScript. Like everything I wrote here is vanilla JSTS. Nothing special exists here at all. One of the cool things is that the strings they use for IDs are branded. So it knows thread.branchParentThread is a thread ID. So it knows branch parent is a thread. If I passed it a message ID instead, it would know this is a message. So you get full type safety at every step. And when I'm in my client here, my update thread mutation has this one function it can ever call. And the optimistic update is directly tied to the one function it can ever call. That prevents a lot of the drift that could be a problem here. And the thing I'm concerned about when I look at this is how easy it is to have drift between your update logic on client and the shape of the things you are passing to the thing that does that update. Ugh. Let's keep reading. Collections support insert, update, and delete operations. These operations must be made within the context of a transactional mutator. So we create an optimistic mutation, which is a mutator, and the mutator has to be passed a transaction. We trigger a mutate function, which immediately applies optimistic state. So to do collection.update, to do, comma, draft.completed equals true. Rather than mutating the collection data directly, the collection internally treats its synced and loaded data as immutable, and it maintains a separate set of local mutations as optimistic state. When live queries read from the collection, they see a local view that overlays the local optimistic mutations on top of the immutable synced data. So you're not actually updating the data from the server, you're creating a copy of it, changing that, and rendering that on top temporarily as you wait for the real data to come back from the server. Funny enough, I actually do this as well. My use thread data hook, this is the hook that calls session query to get my threads that are listed on the sidebar. I grab them from Convex, which is why I have this threads from Convex. One of the things Convex does that I don't like with their hooks is they don't return loading data error states. They just return the thing or undefined as the fallback. So the only way you know it is loading is if it's undefined. And if you could actually return undefined, good luck. I love Convex. This sucks. They know this sucks. It's going to be a fun one to fix. So what I do in order to make sure when you load the beta, you'll see when I load the page, the sidebar is there immediately. I'm refreshing. Sidebar is always there. The reason the sidebar is always there is because I back up the results in local storage. And whenever they change, I update the local storage results. So on first paint, I can return the local storage values if I don't yet have threads from Convex. This is my attempt to skip the whole waiting for the server to respond with the data in order to show the user something faster. It's not the same as optimistic mutations, but it is very similar. And the point I want you to take home here is this custom data thing that I have, threads from local storage, which is the same shape and expectations that we have from the session query from the backend. Here, I return the thread from Convex first, and if I don't have it, I fall back on local store. Imagine if we had flipped this. Threads from local storage gets returned first. Threads from Convex is the fallback. Now, if we make changes here, this will be shown first. And if when this completes, we nuke it, we just, on a change of threads from Convex, we wipe the local store. That's how this works. The magic here is that your state from the server stays pure. It's always the exact thing the server returns. You just have a mirror of it on top temporarily. And the moment you decide that isn't the thing you want to return to your user anymore because you have new data, you just destroy it. It's a very sensical pattern, and I'm excited to see them embrace it. But I am curious how much the implementation details have leaked, because this kind of sucks. The idea that I have to pass this here somewhere in my application logic, separate from the hook I defined up top, I don't love. I really don't love. Oh shit, Convex is here. Good to see you, man. I've been trying to not just glaze Convex this whole time. Yeah. I did compliment how Convex does optimistic updates earlier. It's the least painful I've dealt with. And as much as I hoped for this to go that path, I am skeptical. Back to the docs. The local mutations are passed to the async mutation function that's passed in when creating the mutator. This mutation function is responsible for handling the writes, usually by sending them to a server or a database. Tanstack DB waits for the function to resolve before then removing the optimistic state that was applied when the local write was made. One more quick piece. You might be thinking as you look at the code here, well, I have this too with Convex. The update logic's in a different file. Because if I have my editable thread title here, the code that actually updates the thread title, I have to command click to get to it. And this is a whole different function. There's a whole bunch of different stuff. Isn't that the same thing? This is an implementation detail leaking out of here? No, because that's the backend logic. And this has the same problem too. Despite how much we've just looked at all of this code to do these things, despite the fact that we've written all of this for our mutation, the backend logic still has to be written. Your API call that lets you create a new to-do doesn't exist here still. You have to go write that, validate the user can do that, have the row level security and everything set up properly, all just to make sure the user sees the right thing and has the right permissions to do the thing. So all of that additional backend logic still has to be written. This is just for showing it to you on the client, and we're leaking the abstraction so aggressively still. This is making me long for my original T3 chat solution. I feel bad even talking about this because it's so wrong. But when I started T3 chat, we did some fun things with Upstash. Upstash is a Redis KV. So we have our Redis KV. We have a bunch of clients. So we'll say this is user 1. User 1 has a whole bunch of threads and messages. Let's just say they have threads. It's some crazy array. We'll just say they have like 27 of them or something. And they have messages, another crazier array. We'll say they have 120 of them. The intuitive thing is, oh, every thread and message should just have its own row. But how do I know which messages this user has access to? How do I handle all the logic and all the back and forth there? How do I get all of it synced down to the user without firing thousands of queries and mutations? I had a pretty simple solution. I would JSONify it, then I would gzip it, and then I would store it in here with user 1 as the key, and the value is your gzip blob. And this was honestly magical. It was one of the best data architectures I've ever gotten to work in, as comically simple as it was. The only reason this failed is once the messages started getting huge, people were pasting giant blobs in. The thing we were syncing got bigger and bigger until it was multiple megabytes. And it started to fall apart at that point, especially because we had to sync down the whole multi-megabyte payload back and forth every time. Not great. I have a whole video about the database architecture changes. I'm going to do another one soon about the convex stuff. The point I wanted to make here is that this was beautifully simple, because if the client could do it, awesome. Because the only auth here was that when you wrote to our API, I would take your user ID, which we authenticated was you, and I would write to the DB with that key, and this is the value. So if you wanted to fill it with garbage, you could, and it would sync up totally fine, because I don't care. You can't override another user's things. You can't access another person's stuff. Your key is yours and only yours. And the result was very simple and easy to maintain. And then it fell apart as I had to handle all the crazy edge cases that come up, like multiple devices, or breaking things up into individual message and thread rows, or handling streamed updates when they come through on the fly and have to be resumed. This was beautiful until it fell apart. And I long for this setup dearly still. I wish I could do this again. I know I can't. I know it's irresponsible and wrong. And I'm telling you, do not do this. It's not a good way to do things. But it meant all of the problems we're talking about today did not exist, which was really nice. And when I see this, I see code that is more complex than what I had done there. And it's obfuscating half of it because we don't even see the backend side here. So yeah, benefits and negatives to all of the above. I'm skeptical of this flow. Here is how they diagram it, where a given component will trigger an optimistic state change to the collection, while at the same time, a persist mutation is going to the server. When that happens, a sync comes down to the collection, which nukes the cache that they have on top of the collection when they mirror the data to make the optimistic mutation, and that will then update the component yet again. So why would the architecture end up like this? How did we get here? My hot take with that is this idea of collections. We have this whole section defining collections, which are typesets of objects that we populated with data. It seems like from all the examples they have, they are calling an endpoint with it. To do collection, we create an electric collection. ID, stream options, primary key, schema. This is the deeply integrated version with electric. We give it the URL. We give it the param for the thing we want to do. We want to hit table to-dos. We tell it what the primary key is from the thing being returned. And now we've defined this collection. Does this look familiar to something we saw earlier? Oh, look, they even link it underneath. Shapes and shape streams. It seems like this concept of a shape is very core to how Electric is thinking about databases and sync engines. And rather than rethink optimistic updates on client in a way that made them more consistent and reliable, they were trying to figure out how to fix them for shapes. And this is the hot take I have. Tanstack DB should never have been named Tanstack Optimistic, because that's not what it is. It's Tanstack Optimistic Shapes. And now Tanstack DB might not be best to call Tanstack DB. It's certainly clickbaity and gets a lot of attention in order to get people to watch a video like this one. Hi, thanks for watching. Tanstack DB would be more accurately described as Tanstack Shape Bindings, where it is giving us this idea of a shape that comes from Electric and make it easier to interface with using Tanstack patterns. On one hand, I'm thankful they did this instead of making yet another crappy React client that has to be maintained indefinitely and falls apart. But on the other hand, I think it's misleading, and I cannot imagine many people using this outside of the Electric case. And it almost feels like an ad/top of funnel to get people on Electric, which again is a company I'm invested in that I want to see succeed. I will make a lot of money if they do. This just felt weird. And I remember when I first saw this, I was at a local first meetup and I saw an excited presentation. The repo had 7 stars and I was the 8th. And the more I read, the more skeptical I got, because this idea of a collection does not map at all to the idea of a live local database or a sync engine or just basic optimistic updates that I was looking for. Chat put it really well. It sounds like it's supposed to be a generic, but it is far too specialized to be useful beyond. That's how I feel too. The amount that the implementation details are leaking all over the place here just doesn't feel particularly Tanstacky. Like with Tanstack, you just give it an async function and you're good to go. That's not the case here at all, because the async function you give it, even with something like this, you're no longer getting like any of the benefits of the update, the sync, and all of that. At that point, you would want this to have a subscription of some form. Now you have to define all of your endpoints in the shape of what this expects. I cannot imagine having a great experience with Tanstack DB right now if you are not shaping your backend to fit the expectations of this library. And the point of React Query was the opposite. It lets you not care about the way the backend was shaping your data. You could just call an async function, get what you want, and go on with your day. This does not feel like that at all to me. And I hope they take this feedback as an opportunity, because that's what it is. I desperately want better ergonomics around local updates. The React Query kit seemed pretty good. What I have here with Convex with like a type-safe local store primitive, which is a confusing name. I already told them to not call it that because it's easy to mix it up with local storage. But this is the Convex client's state of the world. This isn't the most fun thing, but it's fully type-safe. If I make a change to type definitions, this will get type errors. It does what it's supposed to. The code I wrote here was exactly what I expected to, and it worked exactly how I wanted it to first try. This is nice. And I was hoping that Tanstack Optimistic and now Tanstack DB would feel better than this and less leaky than this. But what I'm seeing is quite the opposite right now. What I'm seeing here is a huge shift in our database model, thinking about how permissions and endpoints and synchronization work with a PostgreSDB, with implementation details leaking not just into your React client code, but into the libraries that we hold dear, because normally they make our lives easier. If this way of building makes sense to you, I'm sure this library will be very helpful. But I was really hoping it will be more useful to more people, and I hope they take the opportunity to do just that. Hope this was a useful overview of Tanstack DB and what's going on in the database sync engine world. I've been way too deep in this stuff for a while now, and I hope you got something out of it. Let me know what you think. And until next time, stay optimistic.